Think we'll keep this one fairly short and simple to talk about social cognition and social neuroscience. What are we talking about here? We are talking about what's going on in the brain when we are thinking about other people and interacting with other people. And in order to unpack this a little, I think we need to do a little bit of basics on social cognition in and of itself before we talk about social neuroscience. The usual kind of basis of social cognition is typically thought to be a phenomenon called theory of mind. This is a somewhat of an unusual term. I always think of it as an unusual term in psychology because you see a term like theory of mind and you think that we're talking about developing a theory of what mind is scientifically, but no, that's not exactly what we mean here. Here we're actually talking about what we might call folk psychology or naive psychology, which is that each of us, as just individual people, whether we are psychologists or not, we develop our own naive theories about what other people are thinking, right? We develop our own theories about what other people's, what's going on in there, what their minds are like, what is mind in general, from a folk psychological view, not necessarily from a scientific view. So, what am I talking about here? Well, a lot of this focuses on childhood, right? Because children will do things like um, they don't necessarily always understand that mental experience is personal and private. So I can be thinking of something and I can be experiencing something, and unless I share that with another person, then they don't know what I'm thinking and feeling. Children sometimes don't understand this, and they assume that if I'm thinking something, that means everyone else knows it too, right? And so this ability to draw a distinction between what I know versus what other people know, this is part of theory of mind. This is tested very often in what are called false belief tasks. So the classic false belief tasks here is, whoops, I didn't mean to hit that button. The classic false belief task is called the Sally Ann test. And what's going on in this test is that a child is told a story about two characters, Sally and Ann. And Sally has a toy and she's playing with her toy and she hides it in a basket. And then she leaves and she leaves the room and she goes away. And while she's gone, Ann takes the toy and moves it from the basket to a box. And Sally didn't see this happen. So when Sally returns, where will she look for her toy? The correct answer should be obvious. She should look in the basket because that's where she left it, right? But a 3-year-old child, when presented with this particular problem, will say that she's going to look in the box because, from the child's perspective, the child knows the toy has been moved, and they are not quite yet able to separate their own knowledge of what's happened to the toy from what Sally could know or should know about it, right? So they kind of get it wrong, so to speak. But when kids are a little over 4, typically, then they're going to start being able to correctly answer this question. There's a few other variations of this kind of a scenario. They're all called false belief tasks because what's happening is that Sally has a false belief. She believes something to be true that we know is not true, and our ability to separate our knowledge of the truth from Sally's knowledge of the truth is what we call, at least a big part of theory of mind, right? My knowledge is not the same as Sally's knowledge. And so my knowledge is my own personal private knowledge. Sally's is different. And I can draw this distinction and I can think about what I know and I can think about what Sally knows. What I'm doing is I'm ascribing a mind to Sally that has contents that are different from mine. This is all part of what's called mentalizing others, understanding what other kinds of things have minds and what others don't. Another thing that shows up in childhood a lot is this kind of magical thinking where children will sometimes attribute mind to their toys and act as if their dolls maybe have real thoughts and feelings. And and so as they grow out of that, they kind of stop doing that, right? And they start, it's not as if they're just pretending, but in many cases it may be as if they really act as if they believe that their dolls have feelings, right? So they are mentalizing others in this regard, but they're just not doing so very accurately. So as we get older, we get better and a little more accurate at understanding the nature of minds in others. So, if this is kind of at the root of social cognition, one thing I want to say about this theory of mind test, this false belief test, since in the previous half of this video, for this chapter, we're talking about neural networks, and so it's worth asking, do you think a large language model could get this answer correct? If we presented the Sally-Ann test to your favorite LLM, uh, how would it respond? And would it be able to respond correctly or not? And if it does it does that mean that the LLM has theory of mind? I suppose it could, but it probably doesn't, right? It probably means something else altogether. And what that means might have further implications for everything that we talked about in that previous video about neural computing. Because if artificial neural networks can effectively act as a human in terms of responding to questions and solving problems, but their performance doesn't actually reflect the same level of understanding that a human has, then that means that what we've done with the artificial neural network, while it is an effective simulation of human cognition, it is not necessarily uh, an actual model of human cognition, meaning that it is not actually cognitive in nature. It is not a true artificial intelligence in the strong sense, right? So it's not sentient in any sense, right? So keep that in mind. Maybe test it on your own if you want to. I know the answer to this question already, but I will not answer. I will not answer that question in this video. I'll let you go discover it if you want to, and see what you think about it. The answer doesn't really influence where we need to go with this. But if we have this idea now that this is an important part of social cognition, the ability to understand mind in self and mind in others, uh, what's involved in the brain here? Well, first we can talk about mirror neurons. So this is a bit of a controversial one a little bit here, but these neurons were discovered in the 90s. What happens here is that these neurons are active when I observe another person engage in a specific kind of an action, but they also are active when I myself engage in that action. So just as if I could mirror the actions of another person by I see once somebody wave at me and I wave back at them, right? And the exact same neurons now appear to be involved in both the perception of that action as well as the production of that action. That's why they're called mirror neurons, as if I can mirror the action. So maybe they play an important role in recognizing social events like this, and maybe it helps play an important role in social and observational learning. One type of theory of mind is called simulation theory, by the way. And simulation theory says that when I observe another person's behavior, what I do is I run a simulation as if I was that person doing that same action. And I'm trying to put myself in their shoes, so to speak. And we could maybe imagine that mirror neurons play some sort of role in this kind of mental simulation of other people's behavior. Another component of social perception and cognition, especially something that gets studied in childhood, is self-recognition. The question always comes up is that if a baby sees themselves in a mirror, do they recognize that they are seeing themselves, or do they possibly think that's just another baby? So what happens here is that you give the child some mirror time so that they can see their reflection, and get used to the appearance, and then you put a mark on their face, like use makeup or something to put a little mark on their forehead, and then the next time they get in front of the mirror and they see the change, if they think it's another child, then they might just spend more time looking at the mirror and say, hey, you got something on your face, right? But do they do this, right? Do they wipe at their forehead as if, oh, there's something on me, right? And uh, and so we see evidence of this again somewhere typically year and a half to 2 years, some signs of that. And what we find now is that this seems to be aligned to some development occurring in right lateral prefrontal cortex, PFC, and also some development in the parietal cortex as well. By the way, this kind of research has been done on various other animals. Dolphins, they put mirrors in the tanks for dolphins held in captivity. You can get some of these kinds of effects. There are also cleaner fish, uh, cleaner fish like the ones you keep in an aquarium, and they also show these effects. In fact, there's a paper in the modules for the course. Um, there's a paper in the module I labeled "Fun Reading," and check that out because that's one where they do exactly this, but with these particular cleaner fish. Other social things we want to talk about here. So, our ability to get along with others and function socially really relies on emotional regulation, right? So, when we go to school, when we're 5 years old, well, let's back up. When we're 3 years old, if something happens and we get frustrated, what could cause us to get frustrated? Well, maybe the parents take you to the store and you see some candy and you want the candy, and the parents say no, you get frustrated. And what do the 3 year olds typically do? They throw down, kicking and screaming, having a temper tantrum, right? But something also happens with 3 year olds in another social situation. So when they're trying to play games with other kids, more complex games, like say hide and seek, have rules. And you have to follow the rules. And sometimes following a rule means uh, not doing something, even if you might have the impulse to do it right now, right? Like if you're playing hide and seek and you're the person who has to be the seeker, and you got to close your eyes and count to 10 and then go look for the kids. This idea of closing your eyes and counting to 10 might be something that you don't want to do because you just want to go run off and chase the kids, right? And find them. And you don't want to wait and follow the rules and let everyone have a chance to find their hiding spot, right? So if that's what's happening here, and you get frustrated because you can't go chase the kids uh, right off the bat, and you got to wait, then again, you might have a meltdown and you're going to have a temper tantrum. And that means you can't play the game. And if you can't play the game, then the other kids are upset and everybody's upset. And now everybody's got a bunch of crying kids and all this kind of stuff. So the social interaction doesn't work very well when you can't regulate, right? You can't inhibit and say, okay, I know I got to wait and count, you do all the follow these rules, right? So but by the time kids are about 5, that starts to disappear, right? Kids are actually now able to regulate their emotions and inhibit impulses. And this is important because it aligns to about the same age kids start kindergarten. Because in kindergarten, you got to do a lot of that, right? You have to sit in your chair, you have to be quiet, you have to not speak, even if you have the impulse, unless you raise your hand and the teacher calls on you. So there's all these rules that you have to follow. And so that requires some a degree of, self-regulatory behavior here, or even if we think back to the theory of working memory that we covered in the previous chapter, right? Executive function, executive control plays an important contribution to inhibiting that kind of stuff. And where did we localize that in that previous chapter? The prefrontal cortex. So yes, again, we're going to see then that when kids are 5 and 6 years old and they're developing emotional regulation, it's because of some developmental patterns happening in PFC. This continues on through adolescence. And so, as we see social skills changing throughout adolescence and our increasing sensitivity to our social environment, susceptibility to social influence and peer pressure, reward seeking behaviors, risk taking behaviors, this all reflects developmental pathways that involve dopaminergic neurons going from the nucleus accumbens and into the PFC, right? But as this system matures, we then, as in our early adulthood, this then increases our ability to engage in higher level reasoning skills, which also happens to align with another developmental phenomenon, Piaget's stage of formal operational thinking, where we master hypothetico-deductive reasoning. This means our ability to predict the consequences of a decision that we make. And that's important because when it comes to risk taking, we might be risk takers in adolescence because we are not necessarily struggling or that we're not necessarily effectively foreseeing the possible negative consequences of our actions. And maybe we're assigning more importance to the possible rewards that could happen if everything goes well and minimizing the negative consequences that might happen if things don't go well. But once we get a little bit older, that starts to flip a little bit. We start taking the rewards a little less seriously and the negative consequences a little more seriously, and we can estimate those likelihoods perhaps a little bit more accurately. And This is all part of the development of the PFC, so it's very much relevant to higher level reasoning as in executive functioning, as well as our social development as well, and making us more sensitive to others. And so that's all part of our social cognition there. All right. Well, as I said, we would keep this fairly short and sweet, and that is in fact all that we need to say about social neuroscience. So let me know if you have questions, of course.